Crystals. I see a tall, dark stranger in your future. No, not that sort of crystal. Not the woo-woo kind. Speaking of woo-woo, I know that you're here for ham content. In the description below this video, I will put some woo-woo type videos that I did on my encounters with spectres, ghosts, all that great stuff. So if you're interested in that stuff, check it out. In today's episode of The Art of Engineering, we're going to look at crystals, how they function, and we're going to grind one of the FT243 crystals that I've got. Eventually I'm going to do them both, but I'm going to have a crack at grinding one of these crystals to make it oscillate in the 40 meter 7 megahertz band. So this will be my first crack at grinding a crystal, and you're going to come along and see whether I make it work or destroy it.
Let's go.
It was very windy last night, and the end fed half wave unfortunately has bit the dust. We headed off to Woolworths. I needed to get some mineralised water for the crystal grinding anyway. So I thought, well, I'll quickly show you this antenna repair. Mate's given me a computer that he was getting rid of. It's very nice of him. It's working. It's Windows 7, but it'll do the job. And I have HD SDR on here, and we are listening to some airband from Sydney International via the 2 meter antenna that's on the roof.
China 174, contact tower 120, decimal 5, when ready, good day. 170, decimal 5, China 174, good day. Just 531, received Juliet, request taxi.
So what do we need to grind crystals? Well, I don't really know because I've never done it before, but watched a few videos. Obviously we need an FT243 crystal, which will give you a sizable chunk of quartz that we can work with. A slab of glass. Now, bigger slab would be better than what I've got here, but we'll work with what we've got. That's out of an old meter that was falling apart. Some isopropyl alcohol for cleaning up the quartz crystal before we reassemble once we've started grinding and we want to sort of check it. I've got some flat-bladed jeweler's screwdrivers that I'll be using to disassemble the crystal. I'll show you what's inside that in a moment. I have been told you can use water, normal water, but if you've got iron in the water, it could cause problems with contamination of the crystal and whatnot. It's good to keep things nice and clean. So we're going to be using a demineralized water. I got this from Woolworths in the ironing section. I think it was on the cleaning section. So it's just water that's had all of the nasties, the metals and whatnot taken out of it. It's as clean as you can get, basically. And I have some wet and dry paper. Now, obviously, carborundum at the right grade would be a better situation, but here we have some 800 grit wet and dry paper. I've been told 600 is probably the go, but I think 800 will be all right, and it'd probably just be sneaking up on it a little bit more judiciously, which is probably what I should be doing. And what is this? Well, it's PCB material, but why have I got it? Now, on the sites where I've read about grinding crystals, they say to grind for a little while and then to check the frequency, reassemble, check it, continue on. There is rumour that if you've got a piece of metal underneath your glass, that as you're grinding, if you've got it attached to a receiver, which I just showed you now, you may be able to see the noise of the crystal as pressure is applied to it via the direct piezoelectric effect, and you might actually be able to see a little spike where the crystal is resonant, and hopefully as you grind, that little spike will wander up the waterfall. That is the theory. It may not work at all, in which case I'm going to have to just stop and check. But if I can get a rough estimate of what the frequency is as I grind it, wouldn't that be magnificent? No one's demonstrated that yet online, so I'm thinking I might be breaking some new ground here, not in using this process, but in showing whether that works or it doesn't work. It's always nice to prove or disprove something that someone says directly. So, and obviously a bit of tape's always a handy thing to have too. So I'm going to tape this piece of glass onto this piece of metal. We are going to go from there. Oh, and lint-free cloth to clean and dry the crystal once we've done that. So let's get this all set up and disassemble our crystal, and we'll see how we go. We had to run a blade along the edge. There was a bit of glue and whatnot holding it together. Or maybe just years and years of crud. Who knows? Apparently there's a spring in this thing too, so I have to be really careful not to have it fly off into oblivion. Okay, so that's the case. Okay. That's your spring holding it all together. It's got a little grommet. And we have one metal plate. Oh, be careful, George, you nearly smashed it. Two metal plate. Which is a sandwich. And a tiny, and I mean tiny, sliver of quartz. My God. So it's even smaller than I thought it would be. We need to get some water on this, and then I've been told we need to go figure 8 pattern. And the first experiment I'm going to do is just to see whether you can actually see it on the receiver, because I'm kind of excited to see whether that's actually a possibility. Before I do that, Bert, I think I'm going to move all of this stuff onto another bench so that it doesn't end up on the floor. So we've slid it back in the holder. We were just using a clothes peg to hold it in, and we're going to see what frequency we've got now. Fingers crossed it's somewhere above 6940. Okay, we are plugged in. We have a dummy load in place, sitting up close to the SDR. We'll switch her on. Do we have cathode? Yes, we do. Fingers crossed this thing still oscillates. There we go. It has not moved at all. 6940. FT243. So we've come up 3 kilohertz, grinding each side 100 figure eights. So I think the next grind that I'm going to do, I'm going to go 150 on each side and then come back and check it. 1, 2, 3,
4, 5.
Kilohertz up, minus 750 kilohertz down.
We are watching Mr. Hayden and Ham Radio DX talking about SDR console. So some great content there, but I need to just show you now. After I went 150 on one side, 100 on the other. We probably should keep it even on each side, but I was just getting a bit worried I was going too far. But we are now at 6947. So I think the next grind that I do is I'm just going to go all out and do about 300 on each side, and I'm hoping that'll get me close to the bottom of the 40 meter band.
I can do that, and it's actually coming out now through.
Got to be very careful not to knock the corners off this now. It's getting very delicate. The isopropyl alcohol will basically just burn off. We just got to try and make sure that we pick up the dust that's on it. But I will do a really good clean once I get closer. Peg's back on. Let's have another go. We're at 6951, so we're 9 kilohertz now away. So I'm going to do another big grind. I might change the paper as well, and hopefully the next time I'm back, I'm in 40 meters. I'm hoping. I need to be patient. Well, folks, I went from doing a situation where I was looking at how many figure eights I did, to the point where I decided just to grind for 5 minutes on each face at a regular rate of about 1 figure eight per second, probably a little bit more than that. And then I went for a full 10 minutes on each side. I no longer have fingerprints on these fingers, but we went 10 minutes each side, so it's 20 minutes of watching ham radio videos while I'm grinding this crystal. And we are now at, you can see it there, 6999.890. So you can see over there, we're just sitting on the edge of the 40 meter band. I'm probably going to do another, I would say, 5 minutes on each side and see where we end up. I'll just show you the test setup. Another thing that I've decided to do is, because this has quite a strong spring that's holding the actual plates together, and they're magnetized as well slightly, I didn't need the peg. I think the peg was actually causing more problems than it was solving. So that's the test setup. So it's been very easy to put it all back together again and pop it in there and test it. So I think, like I said, I'm going to do, I think it is happening a lot quicker. So 10 minutes took me up 20. So I would say if I do about 5 minutes on each side, that's going to take me up into the bottom end of the 40 meter band. So I think that's what we'll try. I'll probably change the paper as well. Check it out. Green at this side of the screen is the 40 meter band. We are on 7005. So we've made it up into the 40 meter band. It's taken probably half an hour, and fingers crossed. I am going to try and take it up about another, I don't know, I'd like to be a little bit higher up in the band than 7005. So if I can get it up above 10, preferably like 15 maybe, that's where I want to be. So I think what I'm going to do now, do a 7 minute grind on each side. Interesting thing, when you assemble it, pressure on the crystal, all that good stuff when you get it back in the case. Frequency came down a little bit, but we are at about 7013.9, so 7014 essentially. I think I still have to adjust bias and whatnot to get a decent note out of it. This is the Kiwi Online SDR in Victoria, VK3KHZ. I think it's a loop antenna, and so it'd be about, I don't know, 900 to 1,000 Ks away. Listen to this. Let's get it on a CW.
And now for a quick discussion of the magic that is the crystal. Now, obviously, as technology has advanced, the levels of abstraction when it comes to understanding exactly how something works has to change. So a lot of the time, discrete components within a complex system are not fully understood. But I think it's a really good idea to have an understanding of the crystal, because at its basis level, digital electronics is still operating off a clock. When they talk about clock speed in a PC or in a microcontroller, you're talking about something that's derived from a crystal. Even if it's higher frequency that's synthesized from that crystal, we're still dealing with a crystal. And what's incredible about these crystals, these quartz crystals, is that they operate from an effect called the piezoelectric effect. Now, the direct piezoelectric effect is basically this idea that if you take a quartz crystal, and it can be other substances as well, but quartz is the predominant one that's usually utilized, and you squeeze it or deform it in some way, you actually generate a voltage across its surface. So if this little box here that has piezoelectric effect written on it was a piece of quartz, and you were to apply pressure to it in some way, or squeeze it or twist it or bend it, you would generate a voltage across its surface. And that is the piezoelectric effect. Now, one of the other things that happens with this little piece of quartz is that if you were to feed the signal that's generated from the piezoelectric effect back to itself, it will vibrate. And it'll have an equivalent circuit that is a series resonant circuit comprising of an inductor, a capacitor, and the resistance that's inherent in the whole system. Or because you're actually sitting it between two metal plates, you end up with a system that can also be seen to be a parallel resonant circuit. And you will find with these crystals, when you look at their resonant frequencies, that they will have two resonant frequencies. One that is the series resonant frequency, and one that is the parallel resonant frequency. Now, if you want to do a deeper dive on the history of crystals and all that good stuff, credit where credit is due. The Sierra Foothills Amateur Radio Club had a gentleman by the name of Earl, call sign Kilo 6 Golf Papa Bravo. He does a great deep dive on this. Link below to that video. Now, obviously, piezoelectric effect is a great thing, and you can use it for an oscillator, which is what we're using our crystal for. But there's another thing called the indirect piezoelectric effect. So it's kind of like the inverse of this initial direct effect. If you distort the crystal, it generates a voltage. But if you apply a voltage to the crystal, it distorts. And that can be used for things like piezoelectric buzzer, like the side tone in my rig. And it can also be used for things like transducers and all that good stuff. So that is your quartz crystal in a nutshell, but I really think it's worthwhile to watch the aforementioned video and do a bit of your own research as well. Anyway, back to the shack.
Well, talk about a grind. I mean, it really was a grind. Probably don't have any fingerprints left on these fingers. It's nearly 1 o'clock in the morning, so by the time I got it all done, it probably took me an hour or two, but when you consider the price of these FT243 crystals, what price to have a piece of history in a transmitter that I'm going to occasionally run on rocks like this. I'm really happy that I managed to get it done without destroying it. The other one looks like it's going to be harder to get into, but I'll work it out, and I will modify that crystal as well. If you're watching this, I'm probably somewhere in Thailand or Japan by now. I tried to get a few videos in the can before I left. I hope you had a great Christmas, and if it's not New Year by now, enjoy the New Year. I will be seeing you in the New Year, hopefully with some more ham videos. 7-3, and I'll see you in 2025.
When I get back.